This is Karston Evans, and for my ENME351 final project, I decided to make a automatic bike shifter. Here's my processing window. The bike shifts depending on the cadence. Cadence is how many rotations per minute you have when pedaling. It calculates it every 10 seconds based off of how many rotations the crank goes through. If it's above 70 RPM, it'll shift up. If it goes below 50 RPM, it'll shift down. And if you're within 70 and 50, it will not shift. You can change these optimal values and the range, and it will also not shift if you're not pedaling. If you only pedal once or twice, it won't shift. And you can set a maximum gear and minimum gear. Currently we're at gear 2. We're not pedaling the bike, so it says 0 RPM. As you can see, it's on the second ring, so it's on gear 2. I will pedal quickly and it should drop down and shift to gear 3. So here, as I pedal, if I reach above 70, it will shift upwards. 70 RPM. So we just hit 82.5 RPM, so as you can see, it shifted. And now you can see it drop down to the third ring. And the processing code now displays what RPM it was at, and it's on now a gear 3. So I just pedaled a few times, it said 15 RPM. And if it's within those two lines, it's the optimal range and won't shift. So I went up 82.5 RPM there, it shifted upwards. If I slow it down, so now 60 RPM, that's what we want, it doesn't shift. Now if I pedal slowly, even slower, it needs to fall below 50 RPM. Now it shifts back down. So you can see it shifted to gear 3. So how this works is I have a Hall effect sensor right here. It detects magnets. So I have a magnet on my gear. Every time it passes, it will count in my Arduino code, and I can calculate the cadence based off of that. Here are the servos that do the shifting. This one shifts up. It pulls this wire, which is attached to that lever. And this one shifts down, pulls the string, which pulls the lever. I needed a little more leverage, so I added this screw. Here's my circuit. My sensor is powered by 5 volts from the Arduino. The 2 servos are powered by the 9-volt battery, and they receive PWM signals from pins 2 and 4. This is my final code, and thanks for watching.